terms. Surface. A part has surfaces. Features. The features exist on the part. They can be planar surfaces like the individual sides of a part, in which case each of these individual features or surfaces has no size. Feature of size. There can also be features of size like a shaft, a hole, or two opposing planar surfaces. Features of size can be measured for size. Features are cylindrical, spherical, or consist of two parallel planar opposing surfaces. It is from features that datum features are chosen. Surfaces, features, and features of size, datum features, and datum features of size all exist. They are real and can be touched. Datum. Datums are derived from datum features. It can be planes, points, lines, or axes. Datums do not exist in reality. They are perfect and therefore can only be simulated. Datum feature simulators are commonly used to connect origins of measurement for location, orientation, profile, or runout. Some common datum feature simulators are surface plates, angle plates, chucks, mandrels, and machine tables. Feature control frame. Imagine the control of dimensions of this part shown here. The size and location of a feature cylindrical hole is specified with basic dimension. We can now add an allowed deviation also to the feature. Here, the tolerance must be shown as applying to the feature being controlled. Like this, each controlled feature, hole, shaft, slot, surface, etc., associated with a basic dimension is given a feature control frame to show a tolerance. The tolerance that appears in the feature control frame is the allowed deviation from the perfect size or location shown by basic dimensions. Feature control frame continued. A feature control frame has the following: a geometric characteristic symbol, a tolerance zone descriptor, a tolerance of location, a material condition symbol, primary, secondary, and tertiary datums. For our example, the component shown with details of feature control frame would appear like this. Geometric characteristic symbols. Geometric characteristics can be of various types depending upon the type of tolerance. Click each type of tolerance to view their respective geometric characteristics and symbols. Geometric characteristic symbols continued. Click each geometric characteristic to know more. Straightness. One of the surface elements is constrained to lie within two parallel surface planes separated by the tolerance. This means that if any line across the surface is within two parallel lines, the part is acceptable. Flatness. Basically, all the surface elements are constrained to lie within two parallel planes separated by the tolerance. Circularity. All of the points on a cylindrical surface are constrained to lie within two circles. It is a 2D surface form control. Cylindricity. It is an extension to circularity that specifies the tolerance along the cylinder. It is a 3D form control which controls roundness or circularity, straightness and taper. Geometric characteristic symbols continued. Click each geometric characteristic profile of a line. The amount of deviation that is allowed for a surface to float within a certain dimensional range while maintaining the shape or form of each line elements that make up that surface. Profile of a surface. It is the amount of deviation that is allowed for a surface. Geometric characteristic symbols continued. Angularity. It requires that all points on a specified feature must form an angle with a datum. Perpendicularity. It requires that all points on a specified feature must be perpendicular with a datum. Parallelism. All points on a surface are to be parallel to a given datum within a specified tolerance. Geometric characteristic symbols continued. Position. A position tolerance generates a tolerance zone that confines the center, center plane, or axis of a feature of size. It is also capable of confining a surface or surfaces within or outside of a boundary known as virtual condition. Concentricity. Concentricity is a geometric control of the median points of all diametrically opposed elements of a figure of revolution. Symmetry. Symmetry is that condition where the median points of all opposed or correspondingly located elements of two or more feature surfaces are congruent with the axis or center plane of a datum feature. Geometric characteristic symbols continued. circular runout. When dealing with a surface of revolution, this determines the amount of deviation allowed from the central axis. This specifically refers to a specific point. Total runout. This is similar to circular runout, but this applies to the entire part. In effect, circular runout uses two circles, whereas total runout uses two surface planes.